Okay, let's continue with part 2 of our transforming linear functions with horizontal and vertical stretches and compressions. So, similar to when we were translating left and right, up and down, the horizontal stretch or compression, we will be modifying the input right here. So f of x, you're going to plug in for the of x. Vertical is going to be tacked on to the beginning or end. Now, we are multiplying here. When we were doing translations, we were going to add or subtract. So, on a horizontal stretch or compression, notice here it says a factor of b. So, look at how we're not multiplying by b. We are multiplying by the reciprocal, 1 over the factor. So, if you're going to multiply, if we look at our next example right here, if we're going to multiply by a factor of 2, notice I'm multiplying by 1/2 because you have to do the reciprocal. And I'm not just going to multiply by 2, I'm going to multiply by 1/2. And right here, if we're going to do a horizontal compression of 1/2, which is already a fraction, when we do 1 over 1/2, well, you're thinking about reciprocal. So we are just multiplying by a 2. So horizontal stretch and compression, you're multiplying by its reciprocal. Now, when we are doing vertical, you are simply going to multiply the function by the factor. So a factor of 2 here, we're simply multiplying by 2 on the outside of the function, or another way to refer to that are the outputs versus the inputs. Now, vertical, again, of a factor of 1/2, we simply multiply by 1/2. So horizontal, reciprocal, vertical, you're just multiplying by that factor. All right, let's look at a couple examples. Okay, let's look at a vertical compression by a factor of 1/4. So vertical compressions, you multiply the output. So I'm going to start with g of x. It's going to be equal to 1/4 times f of x. Okay, on the outside. So g of x is equal to 1/4, and my function is 2x plus 1. Now I can simply distribute. So my final function is g of x equals 1/4 times 2x is going to be 2/4, but that does reduce down to 1/2. And then 1/4 times 1 will be 1/4. Okay, that's it. That's my function after a vertical compression by 1/4. Horizontal, remember horizontal, we have to do this reciprocal, and we're going to multiply by f of the function. Okay, so horizontal stretch by a factor of 3. So let's start out with the generic g of x equals. So it's going to be f of, now it's not going to be 3x, but it's going to be 1/3 x. Okay? All right, now let's actually put in our function. So it's going to be, our function is 2x plus 1. So 2 times 1/3 x, close your parentheses, plus 1. So when it's like when you're plugging in just a single number, you're still going to plug it in place of that x. Okay, g of x equals 2 times 1/3 is 2/3, and then plus 1. And that is our function after a horizontal stretch. Okay, horizontal compression. So horizontal, same idea. So I'm going to start out with g of x equals. So I want to substitute in the reciprocal. So it's going to be f of 3x, which of course is the same as 1 over 1/3, but you're simply doing reciprocal, so let's just plug in 3. So g of x equals 2 times 3x, close parentheses, plus 1, and then simplify. So g of x equals 6x plus 1. Okay, that is our final function. Vertical stretch. So vertical is multiplied on the outside of the parentheses. So g of x equals 5 times f of x. Okay, no reciprocal here. So g of x is equal to 5 parentheses, and then it's 2x plus 1. So g of x is equal to 10x plus 5. Okay, so the key here on everything we've done, you really are going to have to just work with this quite a bit. It's going to take some getting used to, okay? So when you are doing anything horizontal, you're not just going to plug in the factor. So horizontal stretch or compressions, you're plugging in the reciprocal. And then on horizontal translations, you're plugging in the opposite of the value left or right. Vertical on both, you are plugging in the actual value. So on vertical stretch or compression, you're multiplying the function by the factor. On part 1 of the video, on vertical translation, you're adding or subtracting because remember, you're moving vertically along the y-axis. Okay, any questions we will discuss later in class.